Okay? Knowing what you're looking for. If you know what you're looking for, then this limb, or this, excuse me, not limb, this multi-limb, is not that difficult. And more importantly, it is for motor protection. Okay? Because that's what it says at the very top. Or the purpose of this actually was in the first page, something like that or the other.
Yeah.
And motor protection has to do with more as far as overheating or overcurrent, undercurrent, whatever it is that you want to protect the motor from.
Right.
So motor protection, there's a lot of variables when it comes to motor protection. And like I said, I don't want to not cover it at all. But then again, I don't want to start getting into it to where you can, I mean, we can get into it very deep, real fast. But I just wanted to point it out to you, I mean, how easy it really is. This equipment, while it's very sophisticated, it's not really complicated. It's a lot of simple steps or processes that are put together that make it overwhelming more than anything else. But when you start breaking it down to these lower levels and everything else, and you know how it operates, or how it operates, first of all, well, we know how it operates here because we got the buttons and we got the directions here. So if we can read, we can follow directions very easily. And I can stand here and tell you essentially what, you know, is here, but it's going to take a lot of time. That's what I'm trying to tell you more than anything else. Because it's a lot of buttons, a lot of information in here. And to cover each button, each section, and everything else, just, I mean, we got too many tabs to cover and everything else. So, and then your troubleshooting is a little bit further back, in the back and everything. So if you look down, well, it actually is a logarithm. And you can see how, now that starts getting a little bit hairy there and everything else. So I don't really care about all that technical stuff. I mean, I don't really want to know or need to know. Now, if I'm doing the testing, yeah, I need to know my curve and stuff like the other. When it comes to vectors and stuff like the other, well then, you know, I'm not an engineer. So therefore, all I care about is, okay, I want it protection-wise. I want my set points for my motors and stuff as far as, here you go, my amps, the RTD, the overload, like I was talking about, your relay, your system configurations, your metering set points, stuff like that. Okay, you can go in there and set them, you know, or whatever it is that I'm doing. But once again, I don't know how to explain this to you other than trying to tell you the information is all in here, okay? So, I mean, if you got any questions about how to access it, Section 3.
There you go.
Okay? And we can go over there. Now, the thing is, you got to be careful on these when you go into, you can actually monitor stuff, but before you start going into like the actual values or set points or resets and stuff like that or the other, make sure that you understand what you're doing when you're resetting. Okay? Because if you have a history that you've been wanting to log or monitor and everything else, the other, when you go in there and reset it, you can be clearing it out. That's all I want you to understand. The same thing when it comes to the clear, you know, the clear button. Okay, what is the actual function of the clear button? Well, if you go down to page 3-4, it says it's used in set points or help modes only. In set point mode, it can only be used when a displayed set point has been changed. After a set point has been stored, the clear has no effect. In help mode, the clear key can be used anytime there is a help message on the display. So essentially you're clearing your help message. See what I'm getting at? So you just have to know what all these buttons mean. And I love it because it tells you what the use is for at the bottom. When you can and cannot use it, or you know, when it's effective and not. So if you get stuck, hey, okay, let me go over here. Oh, okay, now I know why I can't. So you do have your manual. And I mean, for a field service guy, an electrician, the technical, your drawings and your manuals are your most important, that you gotta have it.
You got
Yeah.
to have.
I do not have the answers for everything, gentlemen, I can tell you that. If you call me, I'm gonna have something like this, and I'll run to my notes and everything else to give you an answer, unless it's a person, I mean, a piece of equipment that I've worked on so much that it's you know, common knowledge. And even then, there's things that you guys have come up with at times that I don't have the immediate answer, I gotta call an engineer or somebody in our technical support group and everything else to try to get the answer, because I haven't come across that. Right? And actually, it's a lot easier because they're the experts, and it's, to me, it's why am I going to waste my time trying to answer something or look for something when they have the answers a lot more readily available and everything.
They designed it.
They designed it, exactly. See, I don't waste time like that. Some people love to run through the manual and go, you know what, I don't have that commodity as far as time is concerned. And I know that you guys are waiting for that answer, so for me to read this manual or take 2 or 3 days to go through it, when I can call them up, and it might take me 2 or 3 hours to get them versus 2 or 3 days, but they can answer that thing within 2 or 3 minutes compared to the 2 or 3 days that it was going to take me to, you know, to get back with you. And you know, you're hurting at that minute or that point when you use that card to call me and everything and say, look, with what you covered in the class, we forgot this, that, or the other, something that now that's going to be fresh in my mind, and because I've constantly been doing that or something like that, you know, some of these things. But if it's more technical, then I in turn have to say, okay, wait a minute, let me look at my notes or see if I've got something right now. If I don't, let me call somebody and I'll get back with you as quick as I can. But that's the whole purpose, like I said, as far as for that card. So, I mean, you come up to some situation like this is what we'll do. On the meter and stuff like that, or the other, I am not that proficient on these multi-lens. I mean, there's so many of them. You got 269, 249, they're just too many. And then we also have the CPAM, then we got switchers, then we got all these circuit monitors. Circuit monitors I'm a little bit more versed in because I've worked with those a lot more than the newer CPAMs and stuff like that or the other, but the CPAMs are just not any much different than the multi-lens. Actually, I think they're a little bit easier, but still, I'm not as versed on those as I am on the Power Logic stuff and everything else, because I started with the Power Logic, and the more they kept, how can I say, not modifying, but making more changes and adding more options, stuff like the other.
Technology.
Yeah, there you go. The technology or the versions changed and everything else. I kind of kept up with them. But when they come up with a new product, then I really have to start reading and digging into it again and say, okay, what are the additions or what makes this one, you know, the options more sophisticated than the other one, something like that, or what new bells and whistles they put on this one and stuff. So it's just those things, like I said, but I don't know everything. I just want you to know. That's when you call me and you stump me and everything, I'm going to let you know. I'm going to be very honest with you and say, okay, I'll get back with you if I can.
That's when we put Jeff on speed dial.
There you go. All right, so I guess, like I said, we can read and everything else, so I need to go any further on this, right? Okay. Get rid of that one. And the next thing that we had, or our next tab, is I think that we were just talking about. This is that metal enclosed switchgear, which is the HVL. Okay? The HVL all that is, it's a high voltage, the acronym stands for high voltage line interrupter. And that CC is actually saying that it's an enclosed case, an epoxy case on it. I'll show you see, and it says it's made up of modular units containing the interrupters that we're talking. And these are the interrupters. Remember, this is a switch. That's all it is. A line interrupter is a line switch. Okay? And it can be single or multi-bay units. Again, it can be tied together. You can have a whole bunch of them tied together, or it can be a single one by itself, standalone. Okay, and they're shipped assembled for ease of handling. This is what it looks like. It's almost similar to what we just saw a while ago, right? The motor control center, the medium voltage motor control center, it was a little bit different because this is not going to have any contact in it. Remember, this is just a switch. Excuse me, this is a switch right here versus this one right here, that motor control, that with a contact. This is not going to have a contact in it at all whatsoever. You're just going to have this epoxy case on here. and it comes down to the fuses, and then from the fuses, of course, these like surge arresters right here, but from the fuses down here is where it goes down to your load, so your wire comes right. So it doesn't go through a set of contacts and stuff like that to the other, okay? So there, that's the difference, essentially. But it looks almost identical in the front as well, because you're going to have this high voltage compartment as well, the low voltage compartment at the top, and here's your controller bus bar compartment. It says number 1. Of course, there you go. The bus compartment the bus will be coming through there. 11 gauge steel barriers. Bus bars extend continuously through the length of the switchgear, which would be right up at the top over here. Go straight across. Number 2 was that low voltage compartment that we talked about. If you open it up, you would see the the low voltage stuff, and we'll see it out there as well. Has a bolted panel where there are no controls for relays or relays present, because this is not a motor control center. Okay, so there's nothing there. But it's identical, that's what I'm getting at. It's funny how, saying, well, what's the difference? Well, once again, all this is a switch. It has no controls of any kind. To do, the controls that would control this contact and else would be caught up in here. Okay? When I say controls, it actually that could be the permissives that are not connected to the contactor itself, because the contactor would have been at the bottom. The load side, as far as the fuses, we talked about how you actually can twist and turn, pull them out, pull them in. Yeah, that's the mechanism compartment that we were talking about. So we saw there's the mechanism right there, what they could look like. It's called an over toggle mechanism, and that's a standard. And it's supplied with the HVL CC switchgear. It's spring compressed, and the blade is independent of the operating speed because of the spring. So regardless of how slow I go, the minute that spring takes over, it slams it in right. And it's also available for a motor, with motor, for electric. There's that encased. That's more or less like a cutaway side view and everything else. 2 is the fixed contact. 3 is a switching blade. 4 is the shaft, the operating shaft that closes the blades, so it's all 3 blades at one time or whatever. And then as far as the number 1 is the epoxy housing. I told you that Siemens has a switch similar to this that has this SF gas in it. And like I said, this was at Cottage Hospital in California, where they said that they had to recharge it. Well, the Square D unit is sealed for life. So there's, like I said, if this ever escapes, and you're going to know that when you do your high pot, because then it's going to break down. It's not, you're not going to be able to get up to that, more or less general rule of thumb, 2.5 times. And the high potting values we found over here when we did the switch, remember? Yeah. Okay, the same thing. This will have high potting values, it'll be approximately 2.5 times. So on your medium voltage switch here. And even on your low voltage switch here, you got 480, and you actually high pot, not high pot, but measure to 1,000 or even 5,000. Yeah. So that way you know for a fact, if anything's shorted on there. And those are the different pressures for the different kV. And seeing it's used to, the gas itself is used to extinguish the arc. And it's compressed, so there's a, pressurized versus a vacuum. The 3 positions, ooh, excuse me. This is the discharge assembly, and it showed it where it goes down over here, as far as when it, once it opens up, discharges and grounds it. Any residual voltage on the load side of the fuse. And of course, like I said, it's actuated by the grounding switch being closed. Notice how many this danger tag has, because it pertains to that switch and everything. So therefore, you really want, and it keeps coming back to this over and over again. Qualified personnel using the proper PPE. Over and over and over again. Read carefully, because like I said, there's steps of it that require that. This is the operator, and I say operator, I'm talking about this being the operator arm. When you close the switch, notice the position where it's at. It's going to the grounded position. So what you're doing is you're taking it and it shows you what you do. You put the, and you go counterclockwise. Okay? Notice where the handle goes, up the top, because you have one here at the bottom as well. I'm going to show you that in a minute. Switch with the over toggle mechanism. Charging the springs on a stored energy mechanism. And I'm trying to, if you have this one or you have the other one that we just covered, but very similar. You just have to know which one you have. And once again, the fuse replacement. And it's nothing difficult, gentlemen, how to operate this thing. I mean, once you get in front of it, we'll go out there and I'll show you. You're going to see how easy it is. Remember, like I said, the fuses, if you replace one, replace them all. Make sure that the striker pin, here's that high pot value we were just talking about. See?
So replace all fuses.
Yes. And hold the other two as your spares. See how it says apply the voltage? I told you yesterday, for 1 minute with the other two phases grounded. The minute it actually reaches, or the second, or the moment that it reaches your field test voltage, and you check your values and so forth, you can turn it back down again. You don't have to sit there and hold it for that minute. Because if it was going to break, it should have broken by then. And what I mean break, if the insulation breakdown would have occurred, you would have seen it break down. Have you ever used a high pop before?
No.
It's the same thing as a megger. You notice when a megger breaks or when it hits the ground, it does the same thing with a high pot. High pot is no different really, other than it's got higher voltages and everything else, whether it's AC or DC. But what I was going to show you is to say, okay, 5 kV, and I said 2.5 times. So 2.5 times is about 15. Oh, excuse me, no, 12 something or the other. On the AC, it's 14. DC is 20, says 20K. If you do 2.5 at 15, that'll be 37.5,
Yeah.
38K. See, and it kind of falls in between there, you know. So, and then if you do 17, that's going to be what, 34.
Yeah, 35 is 2. And half of that's 8.
So
Well,
40.
8, 9, yeah.
So right on that.
41.
Yeah, 41, 42.
Yeah.
That's what I was getting at. And then you do 27, you're going to find out that it's going to be basically just. So that's why I said a general rule of thumb, if you don't have this that you can't remember, go 2.5 times, you can't go wrong. Because you're going to be approximately right in that range between the two, almost like the other. So it's not going to hurt anything really per se. But you're making sure, more than anything else, importantly, that this is going to be able, the equipment is going to be able to hold that rating at 2.5 times. If it holds it 2.5 times, then you know that your integrity of that bottle or that that gas is inert, it's good, and everything else. You haven't lost your pressure in there. And that's what you're trying to make sure, that it's pressurized more than anything else. On the HVO switches and stuff like that, they're basically the same thing. You're making sure that, especially on vacuum bottles, whenever you high pot vacuum bottles, stuff like that, you're confirming or ascertaining that the vacuum in those models are good. So it hasn't lost vacuum. This hasn't lost pressure, and that's the whole purpose of high pump. Where a megger is you're making sure that there's no grounds per se.
Right.
And that's the whole purpose of the megger. This has to do more with the integrity of the gas or vacuum and something like that, the other of the equipment. Again, recommended inspection interval 1 year. Once again, you're looking at your bus connections and stuff like that, or the other, perform a high pod test against signs of overheating. This is almost repetition of what we just, like I said, the process is the same. You're going to operate everything. You make sure that the bus areas are well ventilated, the filters are clean, and then you come back down to your troubleshooting. So if you have any conditions in your troubleshooting, for whatever reason, or a problem with your equipment out there, and you cannot figure it out with your troubleshooting chart, you can always call the 888-SQUARE-D, or if it's something that's real simple, something like the other, you can say, hey, look, this is what it says, but I don't remember where it's at, or something like the other. You can call me. I'd be more than happy to assist you at that point. Okay, do I want to take a real short break and everything right now, or do you want to take it?
I'm fine.
You're fine?
Yeah.
All right. Okay, because I was going to say, we're actually at the end of this presentation. I didn't know whether you want to take it small.
Yeah, I'll take a small one.
Okay. Why do you do that?
Need to take a dip break? Nah.
Stretch your feet. I'm going to show you the power monitors, the next thing. Oh no, wait a minute. I was wrong. Oops. Number 4 is the 1, 2, 3, 4 QED switchboard. And I'm not going to cover the QED switchboard in any detail because all it is a switchboard, just like the motor control center. So we're going right over here again. It's a switchboard, regardless of where it's at. It's basically a distribution unit that comes there that distributes the power, breaks it down to more sublevels. The only thing that I will cover there, show you, has to do with what we call the buckets.
Okay.
Because you have buckets that are Westinghouse, whatever it is, GE, makes no difference. It's just knowing how to pull the buckets out of the GE, out of the Switchgear stuff. Right.
I've had them out. I've had to replace.
Okay, then you know how to pull them off of the cam.
I've had to replace the components on the back side of it.
On the
On the back side of the bucket.
really? In the Switchgear one?
Yeah.
On the Model 6 or the Model 5?
Fives.
5's, okay.
Yeah, there was a transformer or something on the back side of it that I had to take out and replace.
Is that
years
right?
ago. This is equipment that was put in back in 89, 90. And I got the.
Well, okay, you're saying in the back of it, you don't mean behind the bucket, so you mean as far as the back plate or the back surface of the bucket? Because you got a bucket that you would actually, like you would a box.
Right, it was like a box that I pulled out.
Right, it's a box. What I'm getting at, let's say this is the opening of the box and everything else, and your components are all in here.
Right.
What you're talking about is the bucket, the transformer you had to replace was on back here, not behind here.
I'm thinking it was on the back side.
On the back side of it here?
Yeah.
See, the
Actually, that's where your bus bars plug in.
Right. Right.
There was a transformer or something on the back side that I had to replace.
Really? Wow. See, because we try not to, and that's the whole deal as far as put any kind of
Any kind of components on the back are inaccessible.
inaccessible is work, and that's exactly right. Yeah.
But this was,
That must have been a strange application then at that point, because I have not seen that on any of our
And that
equipment.
equipment is gone now, so.
Yeah. Because I've worked on that Model 4, old stuff that's back in the 50s and 60s almost, and I had not seen anything actually that goes behind the
I got
panels.
pretty decent at reading the prints on these things. figuring them out.
Yeah.
That's where we hired electricians in here and all, so. We have, Robicon equipment down here, which is a VFD for the big pumps. And they call me one weekend and says, my pump won't start, like when I hear. The cell, this thing has 12, 15 cells that slide in racks, and they're stacked 3 high, and they're like, I don't know, they're 4 or 5 wide. Anyway, one of them had exploded. It had gotten so hot that it exploded, and it had 24 capacitors on it.
As far as the drive.
As far as part of the drive.
Yeah, with the power board or the CRC or something like that.
It had 24 capacitors, and then it's got a big circuit board on it.
Right.
All that, and the capacitors had gotten so weak that they exploded. When they started exploding, it just toasted everything, and it burned. And we had the old cheap, 49-cent filters on the panel for dust control, but this thing burned away the filter and burned a spot about this big
on the front
of the panel, and it was a grill,
right,
for breathing,
right,
and it was just amazing. I called the electrician. I said, "You've got to come and see this." And he come up here. He lived in Newton, and he came up here and he's like, "Man, I can't believe this." We had to call Robicon in, and they shipped in equipment to be able to test the other cells, because these cells they're several $1,000s a piece, and I think we're getting Square D or something to Graybar to repair these circuit boards for us now. They're doing fantastic.
Oh, right.